Last time we looked at what the dot product is and how to find it. Today we're going to look at an application of how we can actually use that. If we had two vectors, u and v, let's say vector u was this one and vector v is this one. And we wanted to find out what's this angle theta in between them. We can do that by using the dot product and a definition. The definition for angle between vectors is given by the following formula. They've figured out that it's the cosine of theta is equal to the dot product of the two vectors divided by the magnitudes of them multiplied together. So that's our formula. But more useful to us, since we're trying to find theta, we want to find this angle, not what the cosine of it is. So what we're going to do is we're going to use this one, which is theta is equal to the cosine, inverse cosine, of this, of u dot v over the magnitude of u times the magnitude of v. So there's the formula that we're going to be using to find that angle in between the vectors. So let's look at an example. Let's say that we had a vector u that was the vector 2, 5 in component form, and v is the vector negative 3, 7. Okay, and I want to find the angle between them. We can represent that. We can look at 2, 5 is this vector right here in standard position. That's what u is. And v is negative 3, 6, 7. It's this vector right here. There's v. And so what we're trying to find is what's this angle theta in between them. You don't have to graph them like that, but that just gives you an idea of what we're trying to find. Okay? And so what we got to do is find three things. We have to find what's the dot product of u dot v, what's the magnitude of u, and what's the magnitude of v. So those are the three things we have to find, and we just plug them right in here and use the calculator to find out what that is. So if we do u dot v, so again, remember, it's just 2 times negative 3 plus 5 times 7. So negative 6 plus 35, which is 29. So there's my dot product. The magnitude of u, remember, the magnitude is the square root of a squared plus b squared. So this is the square root of 2 squared plus 5 squared, which is the square root of 29. This one is the square root of negative 3 squared plus 7 squared, which is 9 plus 49 square root of 58. So now what we're going to do is use this formula right up here and plug in what we know. It's the inverse cosine of the dot product, which was 29, over these two things, the magnitudes multiplied together, square root of 29 times the square root of 58. And so then you just take your calculator and we just go second cosine, inverse cosine. I want a fraction, 29 over the square root of 29. And you got a right arrow to get out from under that little square root, and then times the square root of 58. And we can go outside here and put a parenthesis, I guess, if we want. You don't have to do that. But then we hit enter, and the answer to that is theta equals 45 degrees. Hey, that came out really nice. Okay? All right, and that's how you find the angle between two vectors. if the problem is written as something like this. It's written in ij form. It's really not any different. So if u was negative 3i plus j, and v was 6i minus 4j. So again, you could write this as negative 3, 1 and 6, negative 4. And now it's the same thing as the problem up above. All right, one other kind of problem. Could be written like this. Let's say u is equal to 3 cosine of pi over 3 I plus 3 sine of pi over 3 j. And v was equal to, I don't know, let's say negative 2 cosine of pi over 6. Oops. I don't know why I put that parenthesis in there. Oh, I guess that's why, because I want that like that. Negative 2 cosine I plus negative 2 cosine, sine of pi over 6. J. So there's our two forms. So, wait a minute, I don't need those in there. So what I do, it'll be written like that. So what I do is think about this is really the same thing as a number like that. We can actually, we recall from our unit circle, cosine of pi over 3 is 1/2, sine of pi over 3 is root 3 over 2. So this is really, this can be written as 3/2 I plus 3 root 3 over 2 j. And this one, v, can be written as cosine of pi over 6 was root 3 over 2. So this would be minus root 3i, if I put root 3 over 2 in here and multiplied by negative 2. Sine of pi over 6 is 1/2, and it's negative 1j. And so now again, I could convert this even farther if you want. We can go to component form. It'd be 3/2, 3 root 3 over 2. This one would be minus root 3 minus 1. Now we're going to find the angle in between those. So we need three things. I need the dot product, I need the magnitude of u, and the magnitude of v. Okay? Dot product is just these multiplied together. And so if I wanted to work that, it'd be 3/2 times this, which would be a negative 3 root 3 over 2. Those multiplied together. And then these multiplied together would be plus a minus 3 root 3 over 2. So that's two of those. So it would just be minus 3 root 3. Okay? The magnitude of u is the square root of this squared plus this squared. 3/2 squared plus 3 root 3 over 2 squared. Well, 3/2, 3 squared is 9. So it would be 9 over 4. Or you could enter this right in your calculator just the way it is. You don't have to work this out. 3 squared is 9. This squared is 3, so 3 times 9 is 27 over 4. So it's the square root of 36 over 4, which is the square root of 9, which equals 3. Isn't that interesting? Look at this back up here. Did all that work to find the magnitude, and there's the magnitude of it. Okay, I bet the magnitude of V comes out to be -2. And if you see that, then that might provide, if it works out, that might provide a shortcut for doing all this. So it's going to be negative square root of 3 squared plus negative 1 squared. Square root of 3 squared is 3. Square root of 1 squared is 1. It equals 2. Magnitude is 2. It's not -2 because links are always positive. So now what we do is the angle between it then is going to equal the inverse cosine of the dot product, -3 root 3 over the magnitude of u times the magnitude of v. Take your calculator and go ahead and put that in there. Second cosine of fraction -3 square root of 3 over 3 times 2 is 6. And the answer is 150 degrees. Since this was in radians, you might want to convert that back. In radians, that would be 5 pi over 6. Either one of those is fine. And that's what your answer is. That's what your assignment's on today. It really goes back to knowing this formula right here. Find 3 things: the dot product, the magnitude of the 2 vectors separately, plug it in there, and you got your answer.